And we're back. Well, there's two more log properties that we need to talk about. Now, if you get out your calculator, which I've done here, you'll notice that in the left corner, there are two log buttons. There is log, L-O-G, and log, L-N, natural log, right? The common log and the natural log, which means that I should have no trouble using my calculator to, let me scroll this up. So I should have no problem using my calculator to evaluate expressions like this. Our calculators, unless they're really advanced, will evaluate expressions like log of 5 or the natural log of 7. No big deal. Now, what does this mean? Well, this is the power that turns 5 into 10. So there is some power out there that will turn 5 into 10. I don't know what it is. It's not 2. 5 squared is 25. And there is some power that, that turns, let's see, this is log base E of 7, that turns E into 7, i.e. e to the x equals 7. The question is, what are these values? And if we go to our calculator really quick, we can actually find that out. Oops, here. The log of 5 is about 0.69897. So this is approximately 0.69897. And the power that turns E into 7 is the natural log of 7, which is about 1.946. And the calculator has no problem doing that. So why this notation? Well, I should have talked about this earlier, and I'm kind of getting off on a tangent here, but how many of you know what the square root of 4 is? What's the square root of 4? Quick as you can. Go.
2.
2. Good stuff. What's the square root of 16? Go.
4.
4. What's the square root of 27? Is right. So stop right there. Is right, but you could probably tell me that it's bigger than 5. Yeah, can you look at that and tell me that that number is bigger than 5? Yes or no? Yeah. Can you tell me that it's less than 6?
Yeah.
Yeah, so it's some number between 5 and 6. And we all agree that there is some number such that when we multiply it by itself, we get 27, right? The question is, what is that number? And that's what this notation is. It's notation for, hey, there's a number out there that does this, but I don't know what it is, so let's give it a symbol. The square root of 27 is the number that when I multiply it by itself, I get 27, right? Now, you can use your calculator to find that, but the question is, do you believe there's a number out there that turns the number E into the number 7? The answer to that question should be yes, I believe that there's a number out there, but also, no, I have no idea what that is. And so we come up with a symbol for that. It's the natural log of 7. So that's what that symbol is for. It's for the number that will take E and turn it into 7. There's a number out there that turns 5 into 10. It's not 2. It's not 1. It's some number. It's not even. Whoa, what did I write? This is backwards. The power that turns 10 into 5. Holy crap. Yikes. Anyway, there is some power out there that will do this, the power that turns 10 into 5. I don't know what it is. We call that log base 10 of 5 or log of 5. Now, that's what those symbols are for, but why the calculator and what are we talking about right now? Now, that's all well and good. The calculator will handle anything that's base 10, and it'll handle anything that's base E. But when we say something like, what's the power that turns 4 into 12? What power turns 4 into 12? So be careful, it's not 3. 4 cubed is 64. So this isn't multiplication, right? So watch out for that. The second thing is, I have no idea what that power is, but I think that there's a number that does it, because 4 to the first power is 4, and 4 to the second power is 16. So whatever x is, it's a number, it's a number somewhere between 1 and 2, for sure. Because 12 is somewhere between the first power of 4 and the second power of 4. The question is, what is x? Well, even though I don't know what that number is, I can still express it. X is log base 4 of 12. It's the power that turns 4 into 12. That's what x is. And then, ideally, we're supposed to be able to use our calculator to evaluate log base 4 of 12. But there is no log base 12 button on the calculator. So, what are we to do? We're going to talk about the change of base formula. Now, the book has some clever questions in here that use this change of base formula, but most commonly, the change of base formula is used to take a log, like log base 4, and turn it into either log base 10 or log base E so that you can actually use your calculator. So, it looks like this. Log base B of A, or I'll just use X. Log base B of X. The change of base formula is one of two things. Either the log of X over the log of B, or the natural log of X over the natural log of B. These are your conversions for your calculator. This is for using your calculator. In general, log base B of X is, you're going to choose a new base, like, like base C, and the rule is log base C of X over log base C of B. Now, it has been my experience that most students, when they see this for the first, second, or third time, it is overwhelming because there's so many different letters going on here. So, what you need to do is maybe memorize this in words. For all three cases up here, 1, 2, and 3, this is the log of the argument over the log of the new base. So if you have an old base, sorry, the log of the old base, using the new base in both cases. The log of the argument over the log of the old base. So, example. Log base 15 of 132 is equal to Pick a random base value that's not 10 or e. Pick a number.
5.
5. So in both cases, our new base is log base 5. So we're going to convert them both to 5. Now, what that means is we have the log of the argument, 132, over the log of the old base, using the new logs in general. There it is. Now, this is also equal to the log of 132 over the log of 15, and it's also equal to the natural log of 132 over the natural log of 15 in all three cases, using, this is change to base 5, base 10, base E. All of these will give you the same numerical value. So for 4 to the x equals 12, which means that x is the power that turns 4 into 12, that's equal to the log of 12 over the log of 4. And if we break out our calculator, we have the log of 12 divided by the log of 4, and the value we get is about 1.792481, 1.792 approximately. And we'll note that that is a power between 1 and 2, as we stated up here. It's some number between 1 and 2. It's about 1.792. And just to verify that we were close, we should be able to take our answer, take 4, raise it to that power, and what should we get back? Okay, well, the answer is 12. Boom. There it is. Bang. Nailed it. And so that's what you can use this change of base formula for.